All right. So we have dealt with interest before, and we had this little formula that was A equals P 1 plus R over N to the NT, right? And we know what all these letters stand for, right? What does P stand for? Principal, all right? So it stands for principal, but I want you to think this is what you start with. Are we okay with that? Officially, it's the principal, it's your initial value, but think of its starting value. What is A? Short for amount, but the way I want you to think of it is the ending value or what you want. Okay? Are we okay with R is your rate, T is time, right? Are we okay with those? N is the number of times you compound. Now, when I gave you these problems, N could be sometimes you compounded once a year, sometimes you compounded twice a year, sometimes you compounded 12 times a year, sometimes you compounded 240 times, right? And what did you notice? The more times you compounded, did you get more money?
Yes.
You always got more money, right? But did you notice that the more times you compounded, the amount of money you got was less? There wasn't a whole lot of difference between compounding, 12 times a year and compounding 240 times a year, right? And there wasn't a whole lot different when, like even if we compound 1,000 times, right? There wasn't that much difference, right? Well, today we're going to talk about something called compound continuously. Oh, wow. You guys. Okay. Today we're going to talk about compounding continuously. And what is compound continuously? So if I say compound daily, you think, well, you get money every day, right? If I say compound every second, you think, well, I get money every second. When I say compound continuously, I'm saying you get money every instant. And you might think that formula is way worse than this one, but it ends up being significantly easier. And the formula that we use for compound continuously is A equals P E to the RT, where E is that number 2.71828. And it turns out it's much easier dealing with things compounding continuously than it is compounding the other way. All right? So the great thing about this is you already know what the letters are, right? Are we okay that P is still principal, it's still what you start with? Are we okay that A is the amount, it's what we want, it's our ending value? Are we okay that R is rate, T is time, and we know what E? And one reason I like to really use this formula is it spells a word, PERT. Easy to remember. It was much easier to remember when PERT was a shampoo that was popular. I don't think it's popular anymore, so it doesn't work so well. But, all right, so we get this, all right? So we have this lovely formula. So, and there are 4 ways that we're going to use there are 4 types of problems with this formula, and we're going to talk about those 4 types, right? Got it? So, I need the board space, and so this is going to have to go, right? And I'm going to put my little formula up here. And so I have A equals PE to the RT. And so we're going to talk type 1. Okay? First type of problem. Okay? So let's say we start with, we invest $1,000 at 7% for 12 years. Okay. How much money do you have? Okay. Okay. So what we're going to do is we're going to plug in what we know, right? What do you start with? You start with 1,000, all right? So we're going to put A equals, we're going to put 1,000. E, what's your interest rate?
7%.
So could put it in decimal form is going to be 0.07. So I do 0.07 times 12. So the reason I wanted everybody to have a calculator is I want you to type this in. That E button, it's right above the natural log button, right? So everybody type it in. Let's make sure we all get the same answer. So I'm going to type in 1,000 e to the 0.07 times 12. What did we get? I got 2,316, and the banks never give me the round up. Everybody get that? $12, not 1.2.
It looked like there was a point there.
12 years. The only time you put a decimal is for your interest rate. All right. Are we okay with this? All right. And so now,
Where's the log button?
yeah.
Right, you see. Oh, God. Yeah.
But now, here is the one time I can say in my teaching career that you will use this. Right? If you get nothing else out of today, the next 5 minutes could have a dramatic impact on your life. Could. Depends on what you do with it. All right. So, we're going to fast forward a few years for you guys. Most of you, actually I think all of you, you're going to go to college. You're not going to have any money because nobody has any money in college. That's the way it is, right? And then you get a job, right? And you get your first real paycheck. Now, I don't know what your job and I don't know what industry you're thinking about. I can just tell you from a teaching perspective, right? And so I can tell you from a teaching perspective, if you choose to be a teacher, I think they start out at about 40, right? And if you make $40,000 a year, roughly that means your take-home pay is about $2,000 a month. Okay? After taxes, it may be less. I can't remember. I have to play around with the numbers a bit more. And then, great, $2,000 a month seems like a lot until you have things like, okay, I got to have a place to live. An apartment cost, whatever. Maybe you get a roommate, so maybe you get your housing down to $800 or $900 a month, right? Then you have things like food and gas, and all this other stuff, and like just for you to survive, probably $1,300 a month, right? And you think, great, right? I make $2,000, I have to spend $1,300. That's still $700 extra a month. And that's where it's tricky, right? Very tricky. Sometimes that $700 is only $500 or whatever. You think, well, I can buy stuff, right? You want stuff. Everybody wants stuff, right? You've got your hobbies, you've got this thing that you wanted, and you think, all right, I can buy stuff, right? And some people do, right? Right? And this is super hard. You're 22. It's the first time, 22, 23. You've got, I'm going to call it real money, right? Not an allowance or not just like this part-time job. You've got real money. What do you do with it? Here's the challenge. This is too much. But what if? What if you took $200, which seems like a lot, but you have $700, right? If you take $200, and that means you can't do some other stuff, but you take $200 a month. What's that equal a year? $2,400, right? And let's do that for 5 years, right? So what's that? We're doing very basic. So 2,400 times 5 is what? No. 12,000.
Yeah.
There's another zero in there, all right? And here's the part that's interesting. So in 5 years, let's say that you're 25 and somehow you've done that. So you've got 12,000, right? And you take that $12,000, right? Putting in the bank would be silly because it doesn't pay any interest. And like, you could put it in a retirement account. And I can't predict the future. I have no idea how any of this works. Probably your parents are way better at it than I am. But I can just tell you, over the last 15 years, the money I've had in an account has averaged, we're going to say it's averaged about 8.5%. Right? So if it averaged at 8.5%, and we leave it there. Because right now, the question isn't how much money you have at age 25. The question is, how much money do you have at age 65? Right? So wait, from 25 to 65 is how many years? 40. I know it's a tough question, right? And so we go for 40 years. Now granted, it's going to be tough to get that, because you want a car, you want all this other stuff. How much money is that? Type it in. Can't be that much, right? Type it in. I need everyone to type it in. This is probably the most important thing you could do in this math class this year. I want everyone to know, how much does $12,000 at 8.5% get you after 40 years? Can't be much, right?
For 20,000?
359,500.
Over $300,000. Is that a significant sum of money? For me, it would be. I mean, inflation, maybe it doesn't count that much anymore. It will. How much work did you have to do from age 25 to 65?
Well, not any.
Nothing, right? But it was an awful lot of work to save that, wasn't it? That's a big number, isn't it? And that's if you do nothing else. Have y'all thought about this before? Is it something worthwhile thinking about? Right? What?
What if you kept adding money?
What if you kept adding? Well, it's going to be more. And it's a more complicated problem. Yes?
I plugged it in, I guess correctly, and it said error, so.
Oh, 0.085. That's too big a number. 8.5% is 0.085.
Okay.
You have to convert that to a decimal. This is what I hope has some impact on you. Nothing else that I've taught this year or even next year or the year after is going to have any, or you're ever going to really use it in life. I hope you use this, right? And it's only because I want what's best for you guys, right? Like, why wouldn't I want my students to have something like that when they're 65? Right? Just something to think about. And the key is that 40 years, right? Because if you only did it for 20 years, I mean, it'd still add up. I mean, I worked in a school system, and they did forced retirement where they actually, like, you could do your own, but then they said, no, we're going to put money in for you. And this was in 2006. In 2006, it was maybe 12,000. I looked at it today, it's worth 65. I did nothing. So, all right, the key is this time. And the earlier you can do it, the better you're going to be. All right, are we okay with this? Moderately interesting? Right? And, all right. So, all right, I said there are 4 types of problems that you have to be able to do. All right, are we okay with type 1? Okay. Type 2. I want $3,000, and I'm going to invest it at 6.2% for 7 years. So if you want $3,000, so how do we plug in our formula?
So 300 equals P. 3,000, right?
Okay. Well, wait, do we know what we're starting with?
3,000. Oh, no, we don't. That's what P is.
What are we going to end with?
3,000.
We're going to end with 3,000. So we're going to end with 3,000 equals, but we don't know what P is, right? And then I plug in this other stuff, E to the 0.062 times 7. Everybody okay with that? Now, can we agree that this thing over here is going to be a number? So guess what I need to do to solve for P? Take 3,000 divided by whatever that number is, right? So everybody type it in. Here. I will too.
Should we round it? The
Yeah, pennies.
No, the E before we divide.
No, do this, literally type in 3,000
Oh.
divided by, and then do the E to the 0.062 times 7. Everybody get 1943.73? Okay. And so we end up with P is equal to 1943 and 73 cents. It's kind of interesting, like, kind of a real life issue, a real life situation is, all right, I need $3,000, right? And I know I can get 6.2%. So if I can put $1,900 in the bank and leave it there for 7 years, then I'll have the $3,000 I'm looking for. We okay with this type of problem? Okay. Next up, I need the board space. If I could use the whole board, I would have all 4 examples on the board, but I need the board space. Type 3. What are we looking for? What letter are we solving for?
T.
Time. Why?
Because that's what is that for? How long?
I asked how long, right? Does everybody see we're looking for time? So we plug in what we know. How much are we starting with?
15,000.
Okay, so we start with 1,500. How much do we want?
4,200.
I want 4,200. E, what's my rate?
5.056.
5%, and we are looking for time. Everybody okay with that? Huh. This kind of looks like a problem I gave you yesterday, doesn't it? How do you solve for T? Not yet. What do you have to do first?
Divide by 15.
Everybody see we got to get rid of this? All right. So we're going to divide by 1,500, divide by 1,500. Yeah, you can cross the zeros out if you want to. I don't really care. Here, I need to, so we can see what's going on. So this gives us 4,200 over 1,500 equals E to the 0.056 T. Now what do? Now we take natural log, right? You see why I wanted y'all to do that stuff yesterday? And so now we're going to take natural log of both sides. So I get natural log of 40, I'm going to cross those zeros out. 42 over 15. Oh, wait, what can I do? Why did I put natural log here? What do I need to do?
Make it a 1.
Not yet.
Well, you gotta put the...
Pull the exponent down, right? So I pull the exponent down, that gives us 0.056t, natural log of e. And what's natural log of e? 1. And so what do I need to solve? What do I need to do to solve for time? going to divide by 0.056. 0.056. All right, everybody type it in your calculator. Type natural log of 42 divided by 15 divided by 0.056. Everybody get 18.38 years? 39. And so we find out t is equal to 18.38. What did I have? Yeah, I'll do 3 and 6. Did that make sense? Yes.
Why 3 decimal places?
I depends on the instructions. Like sometimes they'll say round to 3. You'll have instructions of where to round. Is everybody okay with that? Does it seem pretty easy? Like you read the problem, you figure out where stuff goes, all right? So, well, there are 4 types. So here's the 4th type. At what rate? What are we looking for?
A rate.
Rate. Everybody okay with that? So it's at what rate does $1,000 triple in 13 years? So let's use our formula again. What do we start with?
1,000.
Is everybody okay? We start with 1,000. So we're going to start with 1,000. E. I don't know the rate. Do I know the time? 13 years. How much do we want? 3,000. Everybody okay? All right, so now we solve. What do we do? Divide by 1,000. That's going to give me 3 is equal to e to the r times 13. Now what do I do? Take natural log. So I take natural log of both sides, and we do that so we can put this down in front. So it's going to give me natural log of 3 is equal to r times 13 natural log of e. But what's natural log of e? It's a 1. So now I natural log of 3 divided by 13. And so what interest rate? This will be a big interest rate. To triple in 13 years doesn't happen. So if you're saying, well, that's a big rate, let's see, what do we have? So what is that going to be? Natural log of 3 divided by 13. Actually, that's not too bad. What's your interest rate?
8.45%.
Yeah. Like when you type this in, you get 0.0845, right? So the interest rate is going to be 8.45%. Does this make sense? All right. I like introducing word problems with PERT. The reason I like introducing word problems with PERT is it's very easy to, when you read the problem, it's easy to say, oh, this is what I start, this is what I want, this is the rate, this is the time. Yes?
So if it doesn't give you a number of times compounded, you automatically assume it's...
It'll say compound continuously. All the problems I'm giving you today say compound continuously. All right? So, does this make sense? Is this an easier formula to deal with than the other one? I think it is. It's much easier to solve for all the little parts. All right, so here is This is for today and tomorrow. There'll actually be something else that I give you on Friday. It's in OneNote, but you're not doing all of the circle problems because I haven't taught how to do them yet. You have a calculator? Well, let me, after I give instructions. All right. We are going to do all of these. All right. The only problems that I want you to do for tomorrow are the ones that deal with money. Right? So you're thinking, which ones deal with money? Oh, 18, 19, 20, 21, 23, and 26. Right? Right? Does everybody see that? Now, there are other questions that deal with compound continuously. They're like population growth and decay, there's some science questions that we're going to do. Those I'm going to address tomorrow. Right? Actually, let me stop this.